So hello friends, welcome you all on this YouTube channel. So let us solve few numerical on JBus algorithm. So this is a simple network that is given to you, and here the bus numbers and bus impedance are marked in this figure, right? And you have to find the bus impedance matrix of this network, right? So bus numbers are 0, 1, 2 and 3. These circle numbers are basically the bus numbers, right? And these 1, 2 and 3 are basically branch impedances, right? Branch impedances. So you have to find the bus impedance matrix of this given network. So how to solve this particular numerical? Let us see now. So here you simply have to start with the reference node 0, right? Start adding a new element with the reference node. Let us first take bus number 1 or node number 1 is being added to the reference node reference node 0, right? This is basically the reference node, right? Numbering is always given in the question, right? So I'm adding node number 1 or bus number 1 with the reference node 0. Then the new bus impedance matrix will be, see, when you add this bus number 1 with reference node, the branch impedance is 1, right? So you simply have to write 1, right? Now in the second step I'm going to add bus number 3 with the reference node 0. So add bus number 3 with the reference node. So when you add this, the new bus impedance matrix will be this one. Now you see here, this 3 is basically new node and this O is basically a reference node, right? So here I told you the rule number 3, in which new element is added with the reference, new node is added with the reference node. In that case, the last row element will be here 0 and here also 0, and last column and last row element will be ZB. ZB is the branch impedance that is being added. So branch impedance is 2. So branch impedance is 2, write 2 here. So here you write 1, that is the earlier old one, right? So this is node number 1, node number 3. This is node number 1 and this is node number 3, right? Now in the third step, that is the last step because only one node is remaining. So I'm going to add old node, that is new node, that is 2, with old node, that is 3, right? So this is new node, this is old node, this is new node, this is old node. Old node is always being taken is always denoted by a small letter I, so I is 3. So that means ZII is basically Z33, and Z33, you know, it is 2 from the earlier matrix. So in this third case, the Z bus new matrix will be, so I'm adding new element with old element, new plus old. So basically the matrix will be like this. Earlier it was 1 and 3, 1 and 3. You copy the earlier matrix, that is 1 0 0 2 1 0 0 2, right? And now here in the last column and last row element, you simply have to transfer the elements. This is the first rule that I told you. So 0 2, you simply copy this last column element 0 2, copy this last row element 0 2, right? And here you write ZB plus ZII in the last row last column element, ZB plus ZII. ZB is the branch impedance that is to be added. So here the branch impedance is 3 between node 2 and node 3, it is 3. So ZB is 3, ZII is basically Z33, so you add 3 plus 2, so this is basically 2, right? So likewise you have completed this Z bus matrix algorithm. You can also write this into simplified manner. Here the simplified matrix you can write like this: node number 1 2 and 3, node number 1 2 and 3. Rearrange the terms like this: node 1 2 3 1 2 3. So it will be 1 0 0 0 0. This is 3 plus 2 5, that is basically Z22. So 5 Z22 Z22, it is 2, it is 2 and 2. So that is my answer, right? So that is the answer. Thank you very much. Thanks for watching. This question has already been asked in your GATE examination. Thank you very much. Thanks for watching. Please subscribe to this channel for all such kind of GATE and IES questions.